All right, take a look at the answers for the dilations. Make sure your answers match. Pause the videos during the time I'm scanning this so you guys can take a look and make sure. This is dilation B. Dilation C. Dilation D. Dilation E.
Can you grab one of these?
Yep. Dilation F. Dilation G. Dilation H. Dilation I. And dilation J. Alright, go back to the video if you need to review any of those. Make sure you guys open up your handouts from the last time to the page that's on the screen right there. Those problems, if you want to go ahead and finish numbers 1, 2, 3, and 4, if you haven't done those, do those right now as you're waiting for me.
Take a look at these. Pretty simple. The dilations, when they give the scale factor, you don't have to change the origin because they didn't say center it at a specific point. Yeah. Coordinates of A are 1, 1. So the coordinates for A prime are going to be 2, 2. Right there. Coordinates of B are 2, 1. So the coordinates of B prime are going to be 4, 2. Everything is multiplied by 2. Coordinates for C are 0, or negative 2, 0. So that's negative 4, 0. An enlargement. So on scale factors, everybody understand you're just multiplying the coordinate by that scale factor? So B prime was 2, 2. B prime was 4, negative 2. And C prime was negative 4, 0. Did you guys have troubles on number 4? Or I'm sorry, number 4. Did any of you guys have trouble on that one? Notice it's written as a mixed fraction. If you haven't finished number 4, can you go ahead and do number 4 for me real quick? I'm going to show number 2 while you're doing that. As you're finishing number 4, number 2, the coordinates I placed up on the screen for A, B, and C. And of course, the coordinates for A, B, C, and D on number 3. I have the coordinates for A, B, C, and D on number 3 as well. I have the coordinates down for number 4 for A, B, C, and D. Go ahead and finish where you're at. I want to go over number 2 and number 3. So if you can finish where you're at, and then let me have your attention. Pause where you're at now. Okay, for number 2, the coordinates are 0, 4. 0 times anything, do you guys agree, is 0? So for A prime, that's 0, comma. Now 4, when you multiply it by 1/4, is a 1. That'll give you 4 on the top over 4 on the bottom, so it has to be 1. I'm going to use that for the rest of them because I see that it's a couple times I got it. For B prime, it's going to be -1. For C prime, -1, -1. All right, that's for problem number 2. So I'm going to go ahead and plot those points. 0, 1, right here, that's A prime. And 1, -1, that's B prime. -1, -1, that's C prime. Okay, for number 2, everybody see that the image got smaller? That's called a reduction. And for number 3, the values are all being cut in half. So A prime, half of 4 is 2, half of 4 is 2. B prime, half of 4 is 2, half of 8 is 4. For C prime, half of 6 is 3, and half of 4 is 2. And for D prime, that would be 3, 3. So my coordinates, 2, 2, 2, 4, 3, 2, and 3, 3. So the image got smaller again. Now the number 1 and 1/2. So everybody go to number 4. 1 and 1/2 is the same. Multiply the denominator times the whole number. 2 times 1 is 2. Add the numerator to that would give you a 3. The denominator stays the same. 3 over 2, when you multiply it by, if you were to do that division, it's the same as saying 1 and 1/2. So I'm going to multiply everything on number 4 by 3 over 2. If you notice A, the coordinates are 2. When I multiply that by 3 over 2, I get 6 over 2, which reduces to be 3 over 1, or just 3. So for A prime, that would give me a 3, 0. For B prime, it would give me 0, -3. Everybody see how I got that one cut? And for C prime, I'd have a negative 3, comma 3 over 2. Now 3 over 2 is the same as saying 1.5, which is the same as saying 1.5. So pretty good. 1.5 of 1 is 1.5. For D prime, that's going to be 3 over 2, comma 3. So when I place those points and I plot them, I'm going to go to negative 3, or I'm sorry, 3 comma 0 for A prime. B prime is 0 comma negative 3. C prime is at negative 3 comma 3 over 2, which is 1.5, so that's C prime. And D prime is at 1.5 comma 3. Are there any questions on any one of those? No questions on any one of those? All right. Go ahead and erase this. Did we get to numbers 5, 6, 7, or 8 at all? Did we do any of them? No? Okay. Let's do number 5. All right, so do me a favor. First, just go ahead and let me show you some stuff first. And then you guys can kind of write some stuff down. Yeah? Okay. Now remember, the instructions say to determine whether the dilation from figure A to figure B is a reduction or enlargement, and then find the values of the variables that are listed. Okay? All right, so first thing is, from A to B, was that a reduction or enlargement? Reduction. So that's a reduction. How about number 6 from A to B? Enlargement. Okay. Is everybody okay how to determine which one is the original? You're looking for A. Okay. Next thing is to find the variables, right? So does everybody see that A is the original? And you guys understand that in a rectangle, opposite sides are always equal? Opposite sides are always equal in a rectangle. Yeah? So before you do anything, you're going to have to solve for x, for y, and for z. Can you tell me any answers already? Or which one can you tell me? Y is equal to 2. You guys see it? Opposite sides of a rectangle are always equal. So you already know that answer. Okay? Now, the next part is, how do I get the other answers? So I want you to keep in mind, we don't know x. But do you see which side x corresponds to on the original image? X and z are the sides opposites of each other. But x on the smaller figure corresponds to what side on the bigger figure? 3. Those are corresponding sides, so we can set up x over 3. Now, would it make sense to throw in, because what we're doing is we're setting up a proportion of the ratio of these sides compared to the ratio of these sides, which means we're going to set up another fraction. Do you think it would be smart to set up a ratio with the letter z in this equation? What do you notice if I start setting up a z? What side does z correspond to? 3. You notice something in the equation? The 3's are the denominator. What else do you see in there? X and z are two variables that we don't know. So we don't want to use sides. And you notice there's 4 parts to these proportions? You only want one of those 4 to be a variable. So we don't want to use that setup. Instead of that, you notice that you have x and 2 on that side of it. So that would give you 3 and 6, wouldn't it? So since I set x and 3, x over 3, then I would have to set what number here first? The 2 or the 6? 2 on the top. Yes? The 6 would go on the bottom. And from there, does anybody remember what to do with the proportions like that? No? Cross multiply. Go ahead and cross multiply. And does everybody get 6x equal to 6? Now solving for x, what would you do? Divide by 6. X is equal to 1. X is 1. Now, Dominic, you said something about x and z. What do you know about x and z? Same. It's a rectangle, isn't it? X is equal to z. Therefore, if x is 1, then z is 1. Do you guys notice I'm using the if and then when I'm saying stuff? That's all those conditional statements. I have all the answers for the variables. Okay? When you guys are doing figures that are similar, that means the angles don't change. Even though one of them is bigger than the other, the angles still are the same measurements. The only things that do change are the side lengths. One of them becomes a miniature version of the other one. And what you do is when you know figures are similar, their sides have to be proportional. That means they have to have a fraction equal to another fraction. Okay? All right, see if you guys can do number 4 then, or number 6. See if you guys can do number 6. I'm going to give you 2 minutes on number 6. I want you guys to try to set it up as best as you can. Okay. Now don't worry if you guys didn't set it up. I need you to try and think of something to do, okay? To figure out, can you set up the problem at all in any form? Okay? Now, the original one is A, from A to B. It's not a rectangle this time. The image enlarged. So the sides that you need to solve for are N and M, right? So over here in the small triangle, do you notice that you have all 3 of the sides? And in the big one, you only have 1 out of the 3. Use that one side that you know and set it over one of the other 2 that are missing. Let's do M. Now if I use 14 over M first, Now I want you to visually look. What number corresponds to 14 on the smaller triangle? 7 over what number corresponds with M? 8. Does everybody agree it's 8? You see that you've got 3 out of the 4 values in the fraction? All right, go ahead and cross multiply and try to solve. Put in that calculator. Oh, right there, busy. And then you want to. Okay. What's 14 times 8? 112. And 7 times n is 7n, yeah? 7n, yeah? Divide by 7. M is equal to, type in 112 divided by 7. 16 exactly? Okay. All right. Can you try to set up another proportion to figure out n now on your own? I'll give you a minute to see if you can set up one for n. Now be mindful, the way I set it up right now may not have been the way you set it up, but that doesn't mean you did it wrong. There's a couple different ways we can actually set this up, okay? We already know what m is, so don't worry about that. Let's try this. Does everybody see what number corresponds to n on the other triangle? 10. So n over 10 is equal to, don't use m, use 14. You notice I used the one of the sides that I don't know and the side that corresponds to it. So now I'm going to set that equal to 14. What corresponds to 14? 7. That's one way you could have set it up. It's not the only way you could have set it up. Go ahead and cross multiply and solve that for n from there. Try to make an attempt for number 7 and 8 on your own. I'm only giving you 3 to 4 minutes, so on your own, try to see wherever you're at. Go ahead and finish that step for me real quick. We're going to go through number 7 and number 8. Now, hopefully you're starting to get the hang of this, but if not, make sure you take extra good notes, okay? Does anybody have anything you can tell me on number 7 that we can do already? All right, did everybody see that? Y is already equal to 2. You don't have to do anything right here. Anybody have a proportion we can set up so we can solve for x or z? Dominic? Okay, good. X over 7.5. Does everybody see that x and 7.5 are on the corresponding parts of that figure? Okay, what did you set it equal to? Perfect. Perfect. You see that he used the x side over the side that corresponds on the other figure. That means he has to use one of the sides on that same figure on the other side of the equal sign. And whichever one of these he picks, he's got to use the corresponding side that goes with it. So he picked 2, 5 corresponds with it. With me? You understand why he didn't use z? He doesn't know what z is. But it's a rectangle. Doesn't x equal to? See? So once he solves this for x, he already knows what z is also. Cross multiply, right? We got 5x equal to, what's 2 times 7.5? 15. And then did you divide? Okay, what'd you get? Alright, perfect. If x equals to 3 and x is equal to z, then you've got, all your values. Did anybody have trouble with that one? Anybody want to give it a shot at number 8? Okay. Alright, 12 over 3. Now, you guys notice 12 is corresponding to 3, so she's using the big side, and the side that corresponds to the same as the little on the little one. So 12 over 3, and then you use 8 over m. And does everybody see 8 and m are also corresponding? Yep, perfect. That gave you 12m, and that gave you a 24, yeah? Okay, and then divided by 12, and you got m equal to 2, correct? Everybody okay with that one? What was your other equation that you said? Because that solves for m. 8 over 2. Oh, okay, so you use these two sides, which is fine. 8 over 2 is equal to 6 over n. That's fine. Cross multiplied, n equal to 12. Divide both sides by 8. What'd you get for that? 2.5. Okay. Everybody okay with that one right then? You could have also set up, you could have done 12 over 6 equal to 3 over n. Okay. Good job. So let's go to the next part. For right here, these find the scale factor, tell whether the dilation is a reduction or an enlargement, then find the values of the variables. The first part is finding if the figure was a reduction or an enlargement. So for number 9, what do you guys think? Reduction or enlargement? You guys can't tell? It's an enlargement. The original always is the letter without the prime symbol. You see this as P prime? So I went from P to P prime. What do you think that point is? Remember in the last class? Remember I had you guys change the origin with your highlighters? That's the center of dilation right now. That's where the dilation is going on. Remember on the last class you guys had to highlight the new x and y axis off of a specific point? That's what that point is. That's where the center of dilation is. Okay? So it's an enlargement. I'm going to just put right here, enlargement. We're going to have to find what is the scale factor. What was everything being multiplied by? And then we're going to have to find the variables x and y. Can anybody help me set up an equation so I can solve for either x or y? Alright, 4 over 12, and those are, everybody see 4 and 12 are the corresponding sides of the original and the new image. 4 over 12 equal to 6 over y. Alright. I'm going to do a dotted line for the original. 6. Go ahead and solve that for y for me. And then I want you guys to set up the other equation to solve for x. What's 6 times 12? What's 72 divided by 4? What is it? 18? Is that right? Alright, so we got y equals 18. Now you guys got to set up something for x. Okay, so you guys can set it up. And then I'll have you guys try to finish it in 1 minute. You guys are going to set up the equations to solve for the variables on number 10. For number 9, we solved for x and for y. Now, when we used the sides to figure out what the scale factor was, because it was an enlargement, we wanted to use the bigger sides over the sides that corresponded to them. Because enlargements are always a value that's bigger than 1. So the k value is always going to represent our scale factor. Okay? All right, you guys are going to try to do number 10 on your own, so let's just 3 minutes. When I'm giving you guys some time to try to figure out, think, what is it that we did in the last problem that we can still continue to use to help set something up? Yeah? If you're struggling, that's okay. And if you don't get them right or whatever, that's not a problem either. Make sure as I'm going through it, though, take better notes. Okay? Anybody want to give it a shot? Enlargement or reduction, you think? Here is P, the original image. This is P prime. It went from large to small, so that would be a reduction. You guys understand how to figure out which one is the original image? Yeah? Okay. Now you can actually set up the scale factor. Okay? Now sometimes the scale factors are not that easy though. Okay? Could we solve the problem for x pretty easily? Yeah. Daisy, what do you think we could set up to solve for x? All right, perfect. Now, before you say anything else, does everybody see the side that represents x and the side that represents 6? It's the small figure to the over the large figure. So whatever she does next, it has to be the small figure over the large figure, and those sides have to correspond, okay? So what would you choose next, Daisy? Good, perfect. All right, is everybody okay with that? Yep. All right, so that'll give me 12x, and then 6 and 5 will give me 30, right? Divide by 12, 30 over 12, what do you get with that? What is it? 2.5? All right, so now we got 2.5 for x. Now, if you're not sure about the scale factor, you got to keep in mind it's a reduction, right? If it's a reduction, the number is between 0 and 1. It's a decimal or a fraction, right? So that means you've got to put the small numbers on the top. The large numbers got to go on the bottom. If I write 5, I put it over what? What side corresponds with the 5? 12. And if I write 6, I have to write it over, whoops, I can't do 6 over 5. That would be an enlargement. I have to do 2.5 over 6. 6. So go ahead and do those divisions. 2.5 divided by 6. What do you get? 0.14666.
0.416.
Oh, 0.4166. Okay, I had it back. All right, does that number match like that? Is that right? Okay, does that number match 5 divided by 12? Yeah? That number right there is your scale factor, which will be used as the letter K, okay? So that's your K value. All right. All right, now the next numbers, 11 through 16, we're going to do those together. We'll write E if it's an enlargement. We'll write R if it's a reduction. And we'll write I if it's isometric. Now, what do you think isometric would mean? You guys don't remember me going over the word isometry? Remember, this is way back in Unit 1. We're already in Unit 3. Isometry. No? Well, if something's an enlargement, something's a reduction, take a guess what you think isometric thing would be. It's equal. The figure never changed. If it's isometric, it's the exact same figure. It didn't get bigger, it didn't get smaller, it stayed the same. Yeah? Does that make sense? Alright. Alright. Number 11, the scale factor is 3.5. Is that an enlargement, reduction, or isometric? That's an enlargement. Alright, number 12. That's the fraction 2/5. That's a reduction. Go ahead and do 2 divided by 5 on your calculator. Is that number less than 1? How about number 13? It's a reduction. How about number 14? Isometric. Notice whenever you have a scale factor of 1, you're not changing anything. How about 15? What is it? Yeah, enlargement. Everybody do 4 divided by 3. You see that you get a number that's bigger than 1? How about 16? Reduction. Do 5 divided by 8. Is that number less than 1? Yeah. Everybody okay? How to check? Like just looking at what the scale factor is, what's going to happen if it's going to get bigger or smaller? Yeah? Okay. All right, the next part is a little bit interesting. It says, given the point and its image, determine the scale factor. So for number 17, which one is the original image? 3,6 is the original image. Does everybody understand? A prime is the new image. Is that an enlargement or reduction, you think? It's an enlargement. You see that the 3 and the 6 became bigger? All right. So if it's an enlargement, then we do the bigger numbers over the smaller numbers. What number corresponds with the 4.5? 3. So we'll go ahead and do 4.5 divided by 3. And what do you get? 1.5? Okay, do 9 divided by 6. What do you get? Same. And you notice that the number is bigger than 1. So the scale factor is a number bigger than 1. That means it's an enlargement, which goes with that statement right there. All right, can you guys try to do number 18 and 19 on your own? The scale factor that we just got was 1.5. Now, had you done it the other way around, that would have meant that it's a reduction, but it wasn't a reduction. It went from 3.6 to 4.5, 9. All right, you guys are trying to do number 18 and 19, okay? For number 18, which one is the original image? Correct. So is it an enlargement or a reduction? It's an enlargement. Notice 1.5 became 3, and 3 became 6. So you're going to write the bigger numbers over the corresponding number that goes underneath it. That's the smaller number because it's an enlargement. So those two should both give you the same scale factor. What is it? What do you think, Corey? What is it? 2? 3 divided by 1.5 is 2, and 6 divided by 3 is also 2. So the scale factor then is k is equal to 2. Yep. All right, number 19, is it a reduction or enlargement? That one's a reduction. Notice the original is 2,5, and it went to numbers that are smaller. So when you're going from, when you're doing a reduction, you're going to do the smaller numbers on the top. And the larger numbers that correspond to them on the bottom. 1/2, does everybody agree you don't even need a calculator for that? That's the decimal 0.5. 2.5 divided by 5, isn't that pretty much 2.5 is half of 5? So our scale factor then is k is equal to 0.5. You notice the number is less than 1, and less than 1 means that that's a reduction. Is everybody okay on how to do that part right there? Yeah? Okay. Go ahead and move over to the next part. The sides of one right triangle. Ooh, they said it's a right triangle. If we wanted to, we could have the Pythagorean theorem set up a little bit, but you notice it said the sides of one right triangle are 6, 8, and 10. And then it says the sides of another right triangle are 10, 24, and 26. So no matter what, there's a miniature version and a big version. They said in the statement, both of them are right triangles, yeah? Okay. So you notice they didn't give me a picture? If they don't give you a picture, you guys have to start drawing things and labeling the picture. Do you notice in the smaller one, the sides are 6, 8, and 10? Always opposite the hypotenuse is the largest side, so what number should be there? Okay. You could do 6 and 8 right here then. And the reason I put 6 on the bottom because that side looks smaller than the other side. What should I use over here on the bigger triangle? What number should be placed right here opposite that 90? 26, good. Over here then we need 24 and 10. Now remember, I didn't have the picture to start with, right? So by looking at the picture now, can I determine if the triangles are similar? I only know one angle measurement in the triangle, and that's the 90-degree angle. I don't know anything about these angles. I know that they're not the same though, because if they were the same, then opposite sides of those angles would also be the same, and they're not the same. Okay. Do you remember what we were just doing right now to solve for missing sides? And how you guys were setting up proportions? Well, you can do this. 6, 8, and 10, set them over the sides that correspond to those on the other figure. So what side corresponds to 6 on the other figure? Okay, okay, how about for 8? Okay, and for 10? Okay, do me a favor, do the 3 divisions, because those are your proportions or your scale factor. No, I don't know if it's a reduction or enlargement right now. If those 3 numbers are not the same, they all 3 have to be the same. If they're not, then those 2 triangles are not similar. What do you get when you get 6 divided by 10? 26. All right, how about 8 divided by 24? What do you get with that? 0.3333? Like that? All right, how about 10 divided by 26? All right, I'll leave it at that. Does everybody agree those numbers are not the same at all? All of those numbers had to be the same if that triangle was similar. So what that means is these triangles, the fact that they're right triangles, that's good, but that's not enough information. One angle and all the sides does not just mean that they're all proportional. You have to actually check that all the sides are the same proportions. Do you understand why 6 and 10 were matched together? Those were the smallest sides of both of them. And 10 and 26, those were the largest sides of both of them.
So could we flip the drawing altogether?
Yeah, you could flip the drawing, or you could have wrote 10 over 6, 24 over 8, and 26 over 10. When you did that division, you still would have got numbers that don't equal each other. Yeah. So are these triangles similar? Not. And where's my proof? Well, my drawings show there's 2 right triangles. That don't mean that they're similar though. My ratios right here that I'm setting up show that the decimals are all different. And that's why that they're not similar. Had these all 3 been exactly the same, then now you can state yes, they are similar. Okay? All right. Any questions on that part right there? No? Okay. All right. I'm going to move on to the next part. So, all right, this handout is what you guys just picked up today. Does everybody know what to do with proportions, how to solve them? Cross multiply? All right, everybody do me a favor, go to problem number 9. Go to problem number 9 on the bottom of the first page. Go ahead and cross multiply real quick for me. On the left, you're going to get 5 times 9. On the right, you're going to get 6 times 7a plus 9. What's 5 times 6, 9? What is it? 25? On the right side, do you think we need to do right there to simplify that? Distribute. So everybody go ahead and distribute the 6 into each term. That's going to give you a 45 is equal to what? Alright. What can I do next to solve? Because I need to solve for A. 54, okay. Go ahead and give me 45 minus 54. Is that 9? Negative 9. Divide by 42 to both sides. Don't worry about negative right now. You know that the answer is a negative number. Just do 9 divided by 42 on your calculator. It's a decimal. What is it? 0.214. Yep, okay. So the value of n is equal to negative 0.214 approximately. Okay. So do you see what's going to happen with some of these? That there's going to be a distribution that you need to do. I'm going to leave those for you guys to finish on at home because I need to move on to the next section. Okay. Is everybody going to be okay with them? Yeah. All right. Can you guys move on then to the... All right, skip that page. I am going to put the answers on the video right here. So right now I'm showing them on the video. So when you finish them at home, you can go to the video and take a look at the answers, see if they match. Okay? Just pause the video at it'll be page 2, math, SGI, O Lemos for YouTube. So right now I'm showing those answers so you guys can check them at home. And just pause those the videos at those points right there in the video so you can check them. We're going to move on though to the next section though, alright? So I'll have you guys check those answers at home, okay? Let's go to this part right here. So everybody go to that part in your handout. And what I want you to do is, I want you to take a look at problem number 1. And just look at the picture carefully. I want you to notice information that's in the picture. And I want you to look for anything that is in the picture, but it's not being actually written down as information. Anything in that picture that is going to be true. And the reason why is because you are going to try to figure out if those pairs of triangles are similar. Now, being similar and being congruent are two different things. If they're similar, one of them is a miniature of the other. So the sides should all be proportional, okay? If they're congruent, that means they're identical. Everything is the same. Now, can anybody tell me anything about the picture number 1, in problem number 1 that you noticed? Similar? What do you notice are similar? Because here's what we got to do. You got to figure out this triangle, is it similar to this triangle? From just the drawing. Okay? But you got to be able to justify it. Is there anything in there that you see interesting in there? What numbers do you notice, Dominic?
16.
All right, let's stop right there, the 16s. Does everybody see that those 16s are for this triangle right here? That means that triangle, we don't know what D to E measures, but I already know that triangle DEU, and I could have said whichever order I wanted to, didn't matter the order right there, but triangle DEU is called what type of a triangle? Not a right. Two sides are the same. It's isosceles. That's an isosceles triangle. So if two sides are the same, opposite angles are also the same. Now notice it doesn't say that in the picture, other than just 16 and 16. You guys have to be able to figure that out though, okay? All right, so there's an isosceles triangle in there. Anything else that you notice in the picture? Anything about the angle measurements that you can tell me if there's any angles that are the same or equal to each other? Give you a hint, are there vertical angles in them? Do you see any? All right. Now, being able to see the vertical angles and then being able to write out which letters make up those angles, those are two different things, and you got to be able to do both of those, okay? Does everybody agree that this angle and this angle of those two figures are vertical angles? Those angles are congruent. Now you can't call this angle U though, because it's included on both of them. So you got to be able to tell me more specifically, how do you say this angle right here? SUT. You could have also went this way, TUS. Okay. The letter in the middle is where the angle that you're talking about is when you're talking, and this symbol right here means angle, by the way. That angle is congruent to what's the vertical angle labeled on the other triangle? Angle DUE. Or you could have said EUD. All right. That part, you guys have to be able to do that automatically, okay? You notice these two things, you just figured those out by just looking at the picture. So now, I have an isosceles triangle. Is this triangle also isosceles, the other one? Cole, you say no, why?
Because those two angles aren't
The sides. Remember sides and angle measurements, they are related, but it's kind of like apples and oranges, I guess. You know, you're talking about two different things. 39 and 40, you guys agree, are not the same number? So triangle SUT is not isosceles. The only thing I have right now is that there's vertical angles that are equal. I need at least two angles in both of the triangles to show that they're equal to each other. I don't know any other angle measurements. The only other thing I can do is check to see if the proportions are the same. 16 over 16, does it equal 39 over 40? What do you think? 16 over 16 is 1, isn't it? What's 39 over 40? What number do you get? Those numbers are close to each other, right? But they're not equal. So that means these sides are not proportional. So are the triangles proportional? No. That means the triangles then are not similar. So right here, do you guys see this little bottom part? It says triangle UTS, and there's supposed to be a little sideways S like that. That's supposed to represent similar, but they're not. This is that triangle is not similar to triangle SUT, or I'm sorry, to triangle DUE. Those two are not similar. If the sides would have been proportional, then yeah, we can prove that they are similar. And what I was trying to use was a theorem called the side, an angle, and the side. Side, angle, side. On the other triangle, I had a side, an angle, and a side. Okay? But it didn't work. The sides were not proportional. Okay? All right. Go ahead and look at number 2. Just take about 30 seconds. Look at the picture. See if there's anything that's important. Any symbols in there that will help you. Okay. Did anybody notice anything in there in the pictures? Any angle measurements? Do you think there's vertical angles in this picture? In order for you to have vertical angles, you need 2 lines that intersect. You see that the triangles do not have any lines that are intersecting that are being shared together at all? So you can't state any vertical angles. Do you notice that you don't know any of the angle measurements at all? You don't even know if those are right triangles. You notice that it doesn't have the little symbol for a right angle in there? The only thing you know is there are all the sides of both of them on it, right there. Since you know all the side lengths of both of the triangles, then you can do one thing, and you can check, are all the sides proportional? Now, how do you know which numbers to set up over each other? Here's my rule. Do the smaller ones, do the smaller figure. You can do the smaller one over the larger figure, or you can do the larger figure over the smaller one. It doesn't matter. The sides should still give you the same proportion. I don't know if there's an enlargement or reduction at all, but I do know that the circle that the figure that I circled right now has 3 sides. The smallest is 8. Yeah. Smallest on the other one is 48. The next biggest would be what? 12, and the next biggest on the other one would be 72. And then the largest on the one I circled is 14, and the largest on the other one is. All right, you need to check, are all 3 of those proportions the same number? Daisy, what number are you getting? 166. Is that the same thing for all of them? Can everybody verify that? Are you getting a 0.166 on all 3 of those? Yeah? Now remember I told you it didn't matter if you would have set the larger one over the smaller one. If you would have done 48 over 8, that would have given you 6. 72 over 12, that would have given you 6. And 84 over 14, that would have given you 6. As long as you're consistent, you're picking the smaller figure and using all those sides and putting each one of them over the larger figure corresponding sides to it. Now, I didn't know which ones were corresponding. The only thing I do know is I know how to put things from smallest to biggest. Does everybody agree these numbers are all exactly the same? That means those sides then are all proportional. So that means the triangles then are similar. So now, when you answer this question right here, yes, they are similar. You have to be very careful the letters that you put in what order. Because do you notice that C, angle C is opposite the middle side, or the middle number? And then angle B is opposite the biggest side. So when you set up and you say triangle, you can't just say GHF or FGH or whatever. You have to put it in a specific order. C C was the middle, opposite the middle number, right? Out of these three, which one is the middle number? 12, 14, or 8? 12. So the angle opposite should be what's written first. F. Okay, what should be the next letter? B is opposite the biggest side, so which of these was the biggest side? 14, so opposite 14 was G, so then G should be next, and then whatever H. So when you write that they're similar, you have to write F, G, H. You couldn't just put GFH or HGF or whatever. You had to make sure they match. The same way you guys see that we use the bigger side to the bigger side on the other one, middle side to the middle side on the other one, and smaller to the smaller side on the other one. Same way we match those, we have to keep that consistent, okay? All right, can you guys try to look at number 3, see if there's anything that stands out to you on number 3? All right, there's vertical angles. See if you can label them like I did on the last one. There are vertical angles in there. I'll give you about 30 more seconds for you just to try to dissect the picture, okay? But there are vertical angles in there. Hopefully you can see them right away. Dominic, are these the ones you're talking about right here? Yeah. Did everybody see those? I just kind of highlighted in green. Those are the vertical angles. Dominic, what do you think are the letters that make up each one of those vertical angles? Because I want to write a statement that says these angles are congruent to each other because they're vertical angles. All right, notice he said M first, then V, and then L. Do you notice he's talking about this angle right there? So angle MVL. He also could have said LVM, okay? That angle is congruent. Notice I have a sideways S with 2 bars under it. If I didn't put those 2 bars, that would say similar. And there's a big difference between things being similar and things being congruent. Okay? What's the other letters for the other angle? Perfect. T, D, or you could have said U, V, C. You guys okay right there? Why can I state that those angles are congruent? What was the reason? They're vertical angles. And vertical angles are always congruent. So notice that the picture is telling you that, but it's not writing it out the way I just wrote it. You have to be able to see that. Okay. Anything else you notice at all? We're given 2 sides on each triangle, aren't we? So now we're back. Is this an opportunity that I could use a side, an angle, and a side on both triangles? So now I know that the angles are congruent already because of vertical angles. What do I need to prove about the sides then? That they're proportional. 14 and 8. So let's say I write 14 over 8. I just randomly chose to do that. What would I have to set them equal to? 49 over 28. Go ahead and check those proportions, see if they're equal. You can either cross multiply or just divide it out. What's 14 divided by 8? 1.75? And what's 49 divided by 28? Same thing? All right, can everybody verify that? Is that right? 1.75? All right. Had you cross-multiplied the numbers, you get the exact same number on both sides. If you want to do that, go ahead and check it. Do 14 times 28. What do you get, Don?
392.
Okay, do 8 times 49. 392 again. Are those sides proportional? Yes. They are proportional, so now we can answer yes, that they are similar, but be careful, don't just throw any letters in any order. If this says triangle VUT is similar to, what order do you think I'm going to use? V is correct. L. VU. Now notice L is opposite 14. 14 is the bigger out of 14 and 8, right? And U is opposite 49. 49 is bigger than 28. So VU, VL, M you said, right, Daisy?
Yes.
Yes, which is correct. Everybody okay with that one? Notice that one was side angle, side on both triangles. I just had to prove that the two sides proportional to the other two sides. Yeah. All right, go to picture number 4. First, I want you to dissect the picture and see if there's anything that you can use to help you. Okay? So I'll give you 1 minute. Let's take a look at number 4. Is there anyone that notices anything that's striking in just the picture? Angles? Are there any angles that are actually congruent?
K and U.
K and U? Okay, so let's make sure K. Now notice K has 2 arcs. And you said U? Does U also have 2 arcs? Okay, now those are congruent. So now you can state K is congruent to U. Or you could actually write angle K is congruent to angle U. Is everybody okay with that? This is the better. I would rather you write it like that. Okay? Is there anything else in the picture? J and T. So you would say angle J is congruent to angle T. And do they both have the same marks? Yeah. Now I want you to remember something. How much do the inside angles have to add up in a triangle? Always. Always 180. Remember the triangle sum theorem? Angle K plus angle J plus angle L should add up to equal 180. That's for the first triangle, right? The other triangle, angle V plus angle T plus angle U. No. I'm using the wrong letter. Everything's right. Plus angle U should also add up to equal 180. Does everybody agree that K is congruent to V? Oh, no, that's K is not congruent to V. Let's see if I want to do that writing. K is not congruent to angle V. K is congruent to angle U. Sorry about that. And J is congruent to angle T. Does this make sense? These two added up together should equal the same as these two added up together since they're both equal to each other. So then what do you know then about angle B and L then? They have to be equal. If they're both, if these two are going to add up to 180 and these two are going to add up to 180, angle B has to equal angle L. And the reason why is because there's a theorem called the third angles theorem. Or another way to refer to it as the angle theorem, all you need is two angles of one triangle, and they're congruent to two angles of another triangle. The third ones have to be equal to each other. There's no other way that could work out, because they all have to add up to 180. So if two angles are congruent to each other, that's called the angle-angle theorem, or in other words, the third angles theorem have to be congruent. So that means that these triangles then are similar. Now be careful, how do you fill in the correct writing of that? TUV? Alright, so let's make sure it's J. So J matched with T. Triangle J matched with T, K matched with V, and L matched with U. Oh, K matched with U, so TUV? Okay, thank you. T and J should match, yes. K and U, yes. And V and L, yes. V and L are the two that we didn't know, but now actually we do know. I'm going to throw something else at you. Since now I know that these two triangles are actually similar, could I just label this with one arc and this with one arc? Oh, you are correct. If I do that, what am I insinuating with one arc? Yeah, all the ones that have one arc are all equal to each other. So I can't do just one arc. I'm going to have to do three arcs. Because if you don't do that, you're just going to insinuate that all these other angles are also equal, and they're not. We don't know. We don't even know any of the angle measurements. Not yet. We'll get to that later. So right now we're just kind of making sure that little details you kind of get that. All right. I'm going to leave you guys to finish number 5 and number 6. Make sure you follow what we've been doing on these, okay? All right. Other than that, when we come back, we're going to be on the following page here, okay? All right. So let's go ahead and clean up your areas. Please tuck in your chairs. And yeah, if you guys can put the calculators back and then try to separate the desks. I want to keep the desks so I can kind of walk around when we start doing a little bit more difficult stuff. I can help people out.